The second type of graphical display we want to discuss for our quantitative variables is what's called a stem and leaf plot. So let's see what that looks like, and then I'll be able to discuss what it means. So we're going to go to Graph, Stem and Leaf, and I am sticking with the age at inauguration example. So let's select that and then not going to do anything else but hit Compute. So this is our stem and leaf plot right here. And one thing that I hope that you notice is if I look at just the overall shape of the stem and leaf plot, if you kind of squint your eyes and turn your head sideways, it looks an awful lot like, shape-wise, what our histogram looks like. And that is what we want to be able to identify, that these two things are telling me pretty much the same type of information. One is just a histogram and one is going to be just our stem and leaf plot. Now, how did they create the stem and the leaf? The left side of the colons here is what's considered the stem. The right side, these digits over here, are considered the leaf. And if you notice, let's just take this first value here, what they've done is they've taken the tens place, and this 4 represents 40, and the 2 here represents 2 as in 42. And then the next value within this would be 43. Moving to the second row, we have a 46, a 46, a 47, a 47, a 48, a 49, and a 49. So just like in our histogram, we've divided this up into groups of 5, or classes in our histograms vocabulary. Classes grouped by 5 years of age. But in addition to having just a single bar that's covering up or hiding all of the data from within, one of the aspects of a stem and leaf plot is I get to see each of the individual ages contained in that particular class width. So it's kind of important for us to be able to see that in this second row we're talking about, there were 2 people that were aged 46, 2 people that were aged 47, 1 48, 2 more people that were aged 49. While I can get a sense for the overall structure of my graph, one of the things I lose here in a histogram is the fact that although I do understand that in this second bar here, there are 7 presidents who had ages between 45 up to 49, I don't really know what ages those people were. So I just know that there were 7 people who fell within that category or class width. I just don't know what their actual ages were. And that's actually one of the benefits of creating a stem and leaf plot. So here I have our same graph we were looking at, and we want to understand not only how stem and leaf plots are created, they're related to the histogram we were just looking at in that it's really just a vertical shape of our histogram, right? It's just the same histogram shape turned on its side. And it's useful when we want to see those individual values, as well as maybe looking for how many times something was repeated. So maybe I know a mode, which we'll see in the next chapter. So the most often value, the smallest value, as well as the largest value in this data set. But the one thing it's not useful for is it's not a very easy way to depict out a large data set. So if you just had a small-ish data set, a stem and leaf plot is going to be a really good way for you to get some just quick information about that data set, shape, range of numbers, individual data points are still being shown. But anytime you get into a really larger data set, it's not the best way for us to be able to display that. Instead, we want to move on into a histogram. So this is our second form of graphical display for quantitative variables.